And science has to do with everything that there is. For example, did you know that there are more bacteria hanging around your body, on you, than there are cells in you? Isn't that wild? And we think, well, we wash our hands constantly. Of course, not all bacteria are going to harm you, but it just means that bacteria, as life forms, like to live everywhere. In fact, there was, at one point, some scientists who found what they thought was a fossil of a bacterium on a meteor that was judged to have come from Mars. There's still some arguments about that. Now, why do scientists not always agree on stuff?
Well, you know, there's evidence. We always have to look for the evidence. And sometimes things get contaminated, sometimes there's error. When scientists work in a laboratory or when scientists are studying something in space, it's all coming through the observation of a human. And humans are imperfect. They make mistakes, they make errors. So sometimes
I don't know about that. I don't make mistakes. Do you make mistakes? All the time.
Well,
it's true, I do make mistakes. I can't tell you why.
George Washington.
That's right. I cut down the cherry tree. So, okay, so how do we know that anything a scientist says is worth listening to?
Well, I mean, scientists have a lot of things put in place to make sure that things are fact-checked. There's something called peer review.
Oh, I think we should figure this out. Peer review. There's another science concept. Okay, peer means a colleague who has some expertise. In this case, peer is anybody who's around you. We're all peers tonight. In fact, it's a funny thing. All the parents are peers of each other. All the students are peers of each other. Here we have a mix of two peer groups, students and parents. And if you considered teachers as another peer group, there would be a third one. And scientists as another peer group. So a peer-reviewed article that a scientist writes is like, well, who here has had to write a paper for school? None of the adults raised their hand. You had to write a paper at some point. Yes? Ah, okay. Didn't think we were. Okay, so you remember what that was like. You turned it in to maybe a teacher who decides to give you a grade on it, right? Now imagine if that wasn't how it worked. You had to hand your paper to everyone in the room. So instead of just turning it into one person, you had to have everybody in the room get their opinion on it. And so if you were writing about rocks, you would want other rock experts to read that paper to get your ideas, to see if your ideas were accepted.
There's one other thing, too, that's really important in science, and is that it has to be an experiment that other people can replicate. If Dr. Shope here sees bacteria on a rock, and I look at this rock and I try to perform the same experiment the same way that he did it, and I don't see the bacteria, I'm going to question his findings. I don't see it.
So, okay, yeah, that's right. So that's why scientists can disagree about things. So have you heard anything in the news lately that makes you wonder about what's happening to the world?
Gas.
Gas?
The price of gas.
The price of gas. That is a serious problem. it tells you where we're at, though, when you pull into a place that's $3.50 and you say, oh, that's cheap. I can remember putting a quarter per gallon. That's how I started driving in 1969. So that's a long time since it's been a quarter. But I remember when it went up to $1, that was a big deal. When we were complaining. But now it's been up over $4. Now, question, of course, why does that sort of thing happen? I mean, doesn't the Earth just have an abundant supply of gas and, you know, we just keep pulling it out forever?
Well, you know, not everyone even agrees on that. Some people say that there's a limit on the amount of oil that's found underground, and some people think that there's plenty of oil to last, you know, another 100 years or even longer. Not everyone even agrees on that basic thing.
Well, you know, I attended a graduate college class at Cal State LA. Didn't have to do with gas, but it had to do with taking water out of the central San Joaquin Valley. You know how California is shaped? We're between two big mountain ranges, the Sierra Nevadas and what do you call the other one?
Another range of mountains?
Yeah. We're between, well, so the San Joaquin Valley, the Central Valley.
The Coast Range.
The Coast Ridge, yeah.
The Coast Ridge, of course.
That's right. I think. So in the center of this is this great agricultural area where most of the food in the whole United States is grown. But there's a picture where they have a pole that's stuck in the ground and a mark that's 131 feet. That's like a 13-story building of where the ground was a century ago. Because the water has been taken out to irrigate the soil, and the soil has slowly packed down. 131 feet change from a century ago. Isn't that wild? Now, I don't know if that's going to happen.
Just 100 years, 131
well, maybe it's,
feet?
Yeah, something.
So a foot a year the ground has been receding?
Yeah, I must have my numbers off.
Maybe it's possible. I don't know. I don't know enough about agriculture.
But what it means is that, okay, so the clouds come across, they hit the mountains, it rains, and for millions of years, it's drained into the aquifers underneath this fertile ground, which is why it's a wonderful place to farm. And then as they started becoming, you know, being able to drill the wells and get more water and irrigate over all this time, it slowly caused the ground to settle down and pack it. So then the water doesn't get replenished under there. And that's a problem because you would want the cycle to keep going, because you'd want it to be replenished so that you could do it all over again. So these are the kind of problems those scientists are trying to figure out some answers to. You know, how is it happening? And these are graduate students studying hydroecology. Isn't that a great word? Yeah, hydro having to do with water, and ecology having to do with how science looks at the environment. Okay, you know what we need?
What?
I need every volunteer in the house to step over here. Who'd like to volunteer? They don't know what they're volunteering for.
Yes. That's a surprise. No one heard. Not much, right?
No, not her. All right, first of all, yes, step right up. Yeah.
Hey, I think we got some volunteers right here, too.